Okay, so today I'm going to be introducing a new type of function. So we haven't seen these before. Normally, when we're dealing with functions, we're dealing with x and y, where y depends on the value of x. So with our parametric functions, what we're actually going to see is we're actually going to have what is called a parameter, which is a new variable that both x and y depend on. So we're going to start out with an example to kind of explain why we need this type of function and how it can come into play. So the example that I have on the board here is throwing a football. Okay? When we throw a football, there are a lot of things that are changing, but the three that we're going to talk about is as we throw a football, the height of the football is changing, the distance that the football is moved is changing, and all of this is changing with respect to time. Okay? So when I'm going to throw my football, when I show the path of the football, all of these are changing. Time, distance, and height. So how does that work? So if we were to look here, let's say our x value, we'll call this our distance that the football is moving. And for our y, we'll refer to this as height. So let's say at time 0, I'm holding the football, so I'm here. So this is at t equals 0. Well, now I throw the football. That football is going to go up, then it's going to keep going, and let's say the pass is dropped, so it goes to the ground. What I'm seeing as time changes, the height is changing, and the distance is changing. So as time changes, the height changes and the distance changes, but it's all with respect to time. After 1 second, the height has gone up and the distance has changed. At 2 seconds, the height has changed, so has the distance. So that's creating this graph and that path of the football. Plain and simple, okay? So we have two variables that are dependent upon our parameter. So I've got an example here where we have x equals 2t. T is our parameter here. So if we were referring to this in our previous example, t would be time. T's not always time. It's just something that x and y depend on. So x and y both depend on t. So what I'm going to do is I'm going to figure out the path of this set of parametric equations. I'm going to plug in values for t. So we're going to go from -2 to 2, and I'm going to plug them in to find my x and y points. So when I plug in -2, 2 times -2, that's -4. If I plug in -1, -1 times 2, that's -2. 0, 2, and 4. I'm also going to take these values and plug them in for y. So when t equals -2, y equals 3. When t equals -1, y equals 0. When t equals 0, y equals -1. 1, I'm going to get 0, and 2, I get 3. So when t equals -2, I'm going to get the point -4, 3. So I'm going to come in, -4, 3. So that's this point at t equals -2. Then when t equals -1, I get the point -2, 0. So this is t equals -1. 0, I get 0, -1. 1, I get 2, 0. And 2, I get 4, 3. So just like we've seen, like the connect the dots to make the cool little hidden animals, we're doing the same thing here. I'm just going to connect the dots. So I'm starting at -2, and I'm going to go in chronological order. So -2, -1, 0, 1, 2. And we go in that direction, so I add these arrows. These arrows are going to show the orientation or the direction of our graph. And there's our parametric equation. It depended on t, so x changed based on t and y changed based on t. Pretty simple, right? You just got to plug it in, figure out your x, y coordinate, and plot them. Okay, come back for the next video where we'll show how they interact between our normal rectangular functions and parametric.